Hello, kiddos. We have lesson 6, parallel and perpendicular lines. So our learning goal is to use the tools to draw parallel and perpendicular lines precisely. That means we're not guessing, we're not estimating, we're going to be using construction specifically to get what we need, and that is perpendicular and parallel lines. So let's start with the warm-up. All right, so 6.1, Math Talk, Transformations. Each pair of shapes is congruent. What does that mean? Okay, what does that mean? Look at P, look at Q. What do you think congruent means? All right, so hopefully you paused it, you thought about it. Congruent means that circles P and Q are the same size. They're very similar, okay? The radius is definitely the same. All right, so mentally identify a transformation or sequence of transformations that can make one shape to the other. What does that mean? I mean, what does transformations mean? All right, P to map onto Q probably needs to go up and to the right, right? Like maybe a translation back in 8th grade. So P would have to translate over up and to the right to map onto Q. What about now? What about AB, line segment AB, to map onto CD, line segment CD? It would just have to, what? Translate down, right? Whoa. What do you think about triangle DEF, right? To, I believe, let me see, JLK, I believe, or JKL. There we go. Because I think I said DEF, so JKL. This doesn't look like a translation, right? So what do you think? Now, there's multiple answers to this. You could have said a rotation, right? Clockwise, maybe 180 degrees-ish, probably a little bit more, right? Or maybe a reflection across my cursor line that I'm trying to draw right here, and then another reflection somewhere around here, right? So two reflections could have taken that. It's very open-ended, isn't it? What about from MN to ST, right? Maybe a rotation. All right, maybe. So, activity 6.2, and let me reset this because that should have been reset. There we go. Very nice. Okay, so 6.2, standing on the shoulders of giants. So what they want us to do is they basically say, here's line M, here's a point C that's not on the line, okay? They said to use a straight edge compass to construct a line perpendicular to M that goes through point C. So we have to meet that criteria. All right, so be prepared to share your reasoning. So I'm going to use a compass. All right, I'm going to center my first circle on point C, and I'm going to create a circle with a radius big enough to where I have two intersection points on line M. So one's there, the other one is right here. Okay, these are my 2 points of intersection. Now, using those 2 points of intersection, I'll use the compass again. And I will start creating a circle centered on one of the points of intersection with a radius that goes out to point C. I will do that again, except on the other point of intersection with the same radius that goes out to C. Do you notice how point C becomes a point of intersection between those two circles? And then I put another point down here for that point of intersection. Then I'm going to create a line that goes through those 2 points of intersection, and aha, we have a perpendicular line, right? That is perpendicular to M that cuts through point C. Very nice, very nice. So try to recreate that on GeoGebra. All right, go through each step that I went through. The tools are slightly different, but yeah, that's an important thing to be able to do. Interesting how we create a triangle. Does that look like an isosceles triangle, right? Or is that an equilateral triangle? That's an interesting idea there. Now, let's move on to the next construction that you need to know. 6.3, parallel construction challenge. So line M again, point C again, but this time they want us to use our tools to construct a line that's parallel to line M that goes through C. Now, what if I told you it's very much the same as the previous construction of a perpendicular bisector with a little bit more added on? So same thing, let's create a circle where we get 2 points of intersection on line M. Okay, our first circle, of course, is centered on C. And we're going to do the same thing. We need a perpendicular bisector, right? So I'm going to repeat the same steps I used last time. Get myself that perpendicular bisector that we did on the last activity. And then, now that we have a line going through C, right? Now we can create some more circles. So let's create a circle on point C. It's a little bit smaller, okay, than the first circle. And then I want to create 2 more circles. One here, going all the way out to that new circle that we created. And it looks like I messed up on that. Let's go out further. That one. And we're going to do one more from here to here. And if you notice, those 2 circles that I created have their own intersection points of intersection. And if you were to create a line going through there, look at that. You got a line that's parallel to line M that cuts through point C. So notice how we need a perpendicular bisector first, and then we actually create another perpendicular bisector, except this time it cuts through C, but it's perpendicular to that line that we created, the first perpendicular line. So when we do that, we end up creating a parallel line to the first line that was given, line M. So definitely watch over that, watch how I did it, and replicate that on GeoGebra. That would be the ideal thing to do. All right, so the summary, we have 2 constructions that you need to know how to be able to construct using GeoGebra. I recommend that you try that and watch back on my steps from previous. Other than that, that is it. Have a beautiful day. Thank you.